we started the HackerRoom. This is the second cohort that we're doing. And we wanted to provide a space for more builders to join us and have access to the ecosystem and the community. And we've been running this now as a residency program, so they can come here, work with like-minded people, get plugged into directly into our community. And we have a lot of them here tonight that have been working for the past 4 months on a lot of different interesting things. And they're going to show you, I think many of them have also worked on many different things for the past 4 months, so you're going to see a few things that they've been working on. We have 11 demos this evening, 5 minutes each, and I'll be on the clock. Some people have asked me for grace minutes. I can be flexible. There will be also some pizza break in between, but very welcome to all of you, and we'll start with the first one, and I will have my phone always too. I don't have the order in my head, but the first one is Daniil, and he's going to be demoing signing video generation. Give Daniil a woohoo!
Hi everyone. Yeah, very happy to share what I've been building. So yeah, as Sif already mentioned, I'm focusing on sign language generation, and basically I have like a short story why I'm doing it. Few months ago, I came across the deaf people who were signing with each other, and I thought there is no way I can chip into the conversation because I don't know it. And then I did some exploration and realized actually the majority of deaf people have problems with reading because there is a huge problem of illiteracy. So it seems like sign language is inevitable. But being an engineer, I'm super lazy at some things, but super, let's say, persistent in hacking. So I decided instead of learning sign language, how can I learn sign language myself, or at least how can I find a way to talk with these guys? So yeah, that's what I've been building. Today I will present the identity preserving sign language. It's not accurate, but I think it serves as a proof of concept. And before I go there, you probably saw different avatars already on the internet, and they look some sort of cartoonish. So I wanted to actually make it more realistic, even like making myself being the signer. Of course, the progress is not staying at the same place, so I think the AI avatars are evolving and we are kind of getting to the right emotions and precision, but not there yet. So what I've been building so far is like a huge Confi UI interface, but anyway. So here you see I have a hello, what's your name sentence. And what my tag does, it basically first glossifies it. So the glossification is a kind of sign language representation in the verbal world. So if I can show you here, it's highlighted. So having like hello, what's your name, being glossified into hello, your name, what? And it's some sort of like a script for the sign language production later. And then having these glosses, I am able to generate the pose sequence or the animation that produces the right sign language sequence. I also extract the facial expressions because actually they convey 50% of the idea in the language using the data sets, how to sign data set, and running media pipe on it. And then to produce the language, I use the Van model, the open source one. So it basically takes the animation, takes my image, yeah, here I am, and produces the video of me signing. Yeah, that's pretty much it. Thanks for your attention and.
Woo! And you finished quite on time, so we have time for questions. Yep.
Hello, hi. Thank you for your presentation. Just like the question that comes to my mind when you started to think to implement a project from scratch, how did you start? For example, did you go, for example, did a Google search or got into the GitHub and see what's there what is there in the GitHub and just like other people done, or as usually just like these days people are going to ChatGPT and say just like how am I going to build this project? I want to know how you started from scratch.
Me being a researcher before, I always try to explore what's there, like in terms of SOTA, what labs are working on. So that's what I started with. Like I checked some labs, their approaches. There are like modular approaches where you do what is actually I am doing, but there is end-to-end approach where you do like text to video directly. So I checked, compared what has high potential, and then I also grounded myself, checking what we have in the open source, what I can base my work on. And then I did some GitHub exploration. Of course, I'm using a lot of open source components, but eventually I imagine myself training the foundational model for that. So yeah. That's basically how I did it.
Yeah, thank you for the presentation. As far as I know, every language has different sign language. So is it for English or?
So this is American Sign Language, yes.
How can you like fine tune to other languages?
Yeah, so it's not as straightforward because actually there is no, they are completely different. So American Sign Language comes from French Sign Language. So there is a high chance they will understand each other, though it won't be 100% understanding. British Sign Language is also pretty similar to American Sign Language, but German one will be completely different. So I think at least like from my experience, as an engineer, I see what data is available, and there is a pretty, not huge amount of data, but compared to other sign languages, it's a huge amount of data for American Sign Language, for German Sign Language, for British Sign Language. So basically, I have my tag currently for German Sign Language and American Sign Language. But further, I think it will involve a lot of data collection, actually, and data engineering to make it multilingual.
Okay, one more question. There were some hands over here. Yeah.
So can you tell us which LLM you use, or to make the classification?
Classification, yes, it's ChatGPT 5.1.
Cool. Thank you so much, Daniil. So next up is Sep, and he is presenting Structured World for Spatially. Woohoo!
Hi everyone, I'm Sep, and work in progress, but I'm going to talk about Gaussian splatting radiance fields and spatial and physical AI. That's the start. So I started, when I joined, I was working on diffusion models, video models to be specific, and at the start I was working on making something like Cursor for AI for some niche domains, and it had unique features like community features to curate, because AI slop is a problem and a real problem, but the definition of a slop differs from a community to community. So the idea was people could have their own communities and define what a slop is within this community. They would have curations, and they would be able to add assets, and it basically reduce the dimensions. There was a space of the things they could create within these communities, as well as view the things that they could. And there was user-owned AI and TEs, so they could, for example, make policies on moderation policies. They could have their own LLMs within TEs, but a lot of consumers didn't really care about all of this. And something like this, with network effect, you need really to maybe invest a lot, spend a lot of money to find out if this is a formula that users want or not, a product that users want or not. So if something that takes a few thousand users before it actually functions, it's very difficult business-wise to make work. So I started a new direction. So still, I want to make high quality AI videos, but now I want to basically bound them and ground them in space and time. And the idea is that let's start with radiance fields. So you've probably heard of neural radiance fields. They are kind of an old technology. You could basically create a 3D representation of the world. You could explore it, and you could do so by taking images of places. For example, the location in Berlin. Now the newer technology is Gaussian splatting, and it runs on every platform. I will run some on my machine. When you can represent scenes in like 20 megabytes, 50 megabytes, you can just load them on your mobile phone even without installing anything. That's a new thing. That opens up new possibilities for products. Now, you can do so. You can create these worlds by using an AI-generated image or even a real image or basically any kind of image with a text prompt. And there are models that, just like video models, they can take input of one or a few images and then create an entire world of it. Today, I will show one of those. Alternatively, you can take real-world images, but for this approach, you need many more images to get something like that looks great. So you take many images, maybe 50, 100, even more, depending on the methods you use. The pipeline can get quite complicated. I'd be happy to tell you a bit on how it works. There are many different methods and many different steps. But first, something like call map is used. There are methods that do not use call map. Basically, for each image, they try to figure out how this image belongs in a scene with other images. And then they create these point clouds, which is what you see on the right. And then there's a final step where you convert these to ellipsoids. Basically, you stretch them, you splat them in directions, and they also have color and transparency. So most of the features are still under construction, but these are the things I'm working on. I will briefly go to show some examples. Yeah, so for example, this is a splat created from a real world scene. And this could be interesting because you could, for example, without closing Berlin or London landmarks, you could make a movie around this in this area. You can basically navigate around it. You can even, because the size is so compressed, and you can even on consumer GPUs run entire cities, like parts of Manhattan, for example. Now, this is done by someone else. This is a synthetic one I generated. It could get better, it will get better, but what you can do is, this is basically, you can navigate it around. Yeah, there are flaws, which are the reason I'm working on this to improve them. You can drag objects, you can resize objects, and then you can use pins to, for example, I will put one here. I can then rotate this around. What happens is, I have to move it a bit up, but the idea is that you can put multiple pins, and you can basically create a map between these pins. So this is location 1, location 2, location 3. Yeah, and once you have all of these, you can create a movie from these. For example, those are 2 objects. They were not part of the splats. Both of them objects are placed, and I create a movie based on that. Thank you so much.
Questions? No questions. Here we go.
So my question is about these Gaussian splats. Yes. Like, how do they work? Like, just like very shortly.
So so you saw the cloud points. So basically, these are points. Then you feed that to something else, and it basically splats them in like this direction. Where basically it makes them ellipsoids. They can have different shapes. They can have different transparency. They can have different colors. But that also means because these are points that are this makes it very efficient in like representing a space. If you want to do physics or things like that, which you can, you have to do some mesh on top of it. So you have to, if you you want to, for example, do embodied agent simulation for this environment, we have to do a lot of work around these shapes, around these Gaussian splats. There are more than neural fields and Gaussian, neural radius field and Gaussian splats, but Gaussian splats is the one that has the most support at the moment. It's good enough for a lot of applications.
Yep, one more question.
Yeah, thank you for your presentation. So for these spatial modelings, usually you need to have like some base model, 3D model, or an image. Like what do you build based on? If you are using images, how many images do you need with which angles?
Yeah, so Colma, for example, which is a method I named, it works on the base, let's say, the entry point for this pipeline. There are also Colma-free ways to do it. Basically, the number of images depends on the method you use. There are methods that called anything tree, for example. We can check it out. You can maybe with space, maybe 50 images, it can create a good-looking splat. But for some methods, you need more than others. And now they are moving on towards the pre-trained transformers, which makes the whole makes the number of images you need and a lot of other problems that come up as easier. It also makes it faster.
Cool. Thank you, Seb.
Yeah, thank you.
Next up is Julia with NewsDrift.
Yeah, hello everybody. My name is Julia. I'm originally a data and ML engineer, and the past 3-4 months I've been part of the HackerRoom, working on a personal bootstrap project related to media and tech. So I'm going to show my presentation. When I first moved to Berlin, I realized that there's a lot of political culture around, so people are way aware of politics compared to where I come from the global south. And it seemed to me very interesting that depending on which social circle you were hanging out, people seem to be very biased in terms of wars happening around us, post-corona, information and all of that. And I thought, wouldn't it be great that, and I could see that depending on the people that you were hanging out with, I could see a drift, a bias on the signal, on the media and the news they were consuming. And I thought, wouldn't it be great if we just had a common platform where instead of waking up in the morning and maybe checking Axel Springer or New York Times or another media, local media outlet, wouldn't it be great if we had a common platform where all these articles are aggregated from different media sources, and then we have a bigger overview of what's happening. Hence, we could, in a way, fight bias and misinformation, because then we would be consuming information from all spectrum of media, like from very conservative outlets to central and then left outlets. And I call the project NewsDrift because I could see this drift in the signal based on what people consumed. And here is, I'm going to show a little demo. What I use for this is that the tech stack is, I'm using Gemini to normalize data, and I'm using Tavily as a source, is a paid per subscription tool which crawls different websites based on the search that you give. So basically you define what kind of outlets you want to crawl the data from and what kind of topics are you interested on, which could be human rights, immigration, Russia-Ukraine war, whatever your interest is, and then it crawls all this information from all international outlets, and I aggregate them through topics. And the idea, and yeah, and then I could show a very small, I can show it a bit live, how it works. NewsDrift, yes. Here, for example, I have the case where there are different topics that I'm interested in: national and liberal politics, migration policy, environment and climate change, and tech and VC. And here we can see that for migration policy, we get the articles from different media sources. This one is from LA Times, this one is from Associated Press news, etc. If we look at another subsection, environment and climate change, we can also here see an aggregation that is coming from different sources, and so on and so on. And how can I go to the next? Here, yeah, to the presentation. So this gives us basically a less biased, this common platform gives us a less biased information, because then we'd be seeing the news in all spectrums of media. And I took this a step further, which is more on progress now, is that I don't want to just do the aggregation through different media outlets, but I also want to see that how each article is being represented. So for that, there's an open source information there called All Slides, which basically give these media bias charts and shows us which outlets lean more left, which one's central, and which one rights. And basically, if you send the article, they have an open API, and basically they look for political bias in the article. So now what I'm doing, the next step is that all the articles that have been aggregated can also be then checked for political tags and semantic on their articles, which gives a more represented view where a certain article leans more towards to. And here's a small video of how it looks right now. So basically, you can choose the topic you are interested on, the number of articles that are being crawled, the language. In this case, we have English. It's a little bit blurry. And, full screen. And then Tabila, it's being used as a tool to crawl the web. And it's because it's a real-time fetching pipeline, so basically it takes a little bit till all the pages that are defined are being crawled, and then here we have an aggregation through the topics that can be defined. And then that can also be a choice of the user which topics they're interested in. Like if there are more people interested in tech, then there's startup and VC, data engineering. If they're more interested in politics, migration rights, then it's up to users' choice to decide which kind of information they want to consume. Yeah, here we go to like morning briefing. And that's it. That's NewsDrift, basically.
Oh, that went up fast. I think you have an exciting question.
Yes, I was waiting. Since you are detecting the bias on media, I was wondering if your language model also has some kind of bias, which you also have to take into account, because like, who watches The Watchmen?
Yeah, that's a very good question. So right now, I'm more relying on like all sites, which has basically, they have published papers that are highly credible, and it's way more reliable, and it's also used by other companies as a hugely reliable platform. That's why I'm relying on their API right now, because if I were to use a completely in-house model, then as you said, I'd be also very biased on that, because evaluating it would be very difficult. So that's the solution at the moment.
Yeah, hi, I love this. I feel like this problem is a really big one. But people really like being in their own little information bubble. So how do you think you could get people motivated to actually go to separate sites to look at sources that kind of break their worldview?
That's a very good point. Like sometimes people prefer to stay on their own thoughts, but I think talking about such issues, and also maybe also me today talking to a community like that, kind of also breaks a little bit the cycle that, hey, we don't have to just trust a certain source, but maybe we can try and have a common platform for everyone, and then see that there are also different opinions out there, and we can maybe break a little bit those cycles of like having, if someone is very conservative, trying to have more liberal view on certain topics, and maybe the other way around, and then everyone can find a common ground of what they stand by on certain beliefs.
One more question. Right there, yeah.
So I have one question. Have you looked into it as a product?
Sorry?
Have you looked into it as a product, or is it just for as a hobby project?
It started as a hobby project, and I talked to a few people that might be interested. It's very difficult to go to the market with such stuff, but it could be an interested pay for subscription kind of product. So basically, like a Medium, like you pay for Medium article. This could also be an open platform for someone that tries to reinforce himself to not only consume media from certain outlets, but wants a more diverse information.
Yeah, I guess you can check maybe Informed. It's like was one of the co-founders of the Spotify founded it.
Okay.
Because it's on the same problem, but it's, as this friend also said, it's really hard to monetize such product because the users are not really willing to pay for coming out of their comfort zone. Okay. So they actually, the team was quite a big team, large team, so but they had to pivot from it. Informed,
it's
yeah.
Okay, thank you very much. That's gonna have a look at.
Thank you. Thank you, Julia.
Thank you.
Next up is Youssef with local context engine for AI-aware code understanding.
Hi everyone, I'm Youssef. I've built Noodlebox, which is basically a way for your agents to access the context that they're trying to access during your coding sessions. So during my time at HackerRoom, I've spent quite a significant amount of time. Actually, I spent around a year and a half trying to figure out the most optimal way to store context and retrieve it. So basically the problem is current AI agents are pretty much flying blind into your code base. They're making guesses. I call this grep and pray. So they guess certain terms, they find some random results, and they try to make the best out of it and find their way out of, obviously these are sort of the symptoms of what we feel today. Things like, you're working on a part and then you don't really see the full picture. You integrate that part with the other part and then, you don't get what you really expect. So a few of the problems that we experience today. I mean, it's sort of obvious, but naturally engineers would do something like this, the way they organize their code. And today, that's not really good. That's not really good for LLMs because they sort of do this, but internally after reading a lot of files. And the goal is to organize information that way so that it's semantically divided and their boundaries are easily digestible for LLMs. So sorry, we'll have, yeah. So I mean, of course, when you feed a bunch, let's say you feed 2 or 3 files into the LLM, this is sort of what goes into the context window. So we have 2 things that are related and 2 other things that might not be related. And again, the goal is we want a clean piece inside the context window that is semantically divided, while informing the LLM that you got a connection, you got connections with this other flow if you would like to tap into it because it's relevant to the task that you're doing. I prepared a little bit of an animated. Okay. Yeah, That's all right. That's okay. We'll just jump to the demo. So I have 3 splits in the screen. I basically built Noodle, which is a CLI tool. It's all local, and I've already cloned a few. I already cloned a few open source repositories here, FreeCodeCamp, cal.com. I'll be using cal.com as an example for today. Okay, so what it's gonna basically do is it will go through. Actually, let it do its thing while I go back to the presentation and explain what it's doing.
It's okay.
Yeah.
Continue.
All right. So what it's doing is it's basically parsing all the files of the code base. It's extracting entities. It's also resolving the different symbols, like a function calls this function over these files or these modules, and then it builds a scope graph of the entire code base. I'm not using LSPs, by the way, so I built a proprietary engine that is as accurate as LSPs. I do a clustering of the communities of the graph. I trace execution flows of the code, and then all that gets stored into a local embedded GraphDB called Kuzu, which is accessible over MCP. So then your agents get to query this hierarchical semantic graph. This is an example of how a execution flow would have been traced and stored. This is an entry point into your API for registration. So we got all these 6 functions calling each other. If your agent were to search or use the MCP, if they were to semantically, let's say, get one of these hits on any of these nodes, the entire scope will be retrieved, and then they're aware of what's going up and what's going down and left and right in a single query. This is sort of experience, how would it look like? So you got an agent here, you're asking it to do something, it's reading files, it's grepping, takes maybe, I don't know, 40 seconds, a bunch of tools being used. Here, on the other hand, you got a single query, you got the whole context, and it's aware of what it needs to be aware of in relation to the query. Okay, so finished. You can set up, you can configure your agent. Yes, yes, yes. So do Noodle MCP. Now you got your MCP running locally. All right. Reconnect. I got a few prompts here ready for the presentation. So the MCP has generated a resource over an the tool has generated a resource over the MCP. Maybe, I don't know, maybe people are not very familiar with resources, but basically they are pre-generated content documents. So if I do cal.com, I'm pretty much selecting a piece of context of the code base that has been modeled through the agent, through the tool. And then I'm asking it to create modules from this map. While that happens, I took an example. This is the codebase opencal.com. There's this method called create attendee record, and I would like to refactor this. Instead of an attendee, I would like it to be a list. So I'm just going to demonstrate how that would work. Create an impact analysis if you were to modify this particular method to allow a list of attendees. A bunch of MCP calls are being called here in the center. Oh. Sorry, this is taking way too long. I'm really sorry.
We'll do a few questions.
Yes. So as you can see, actually here, it's making a few MCP calls, and it's generating Cypher queries to query the DB based on the relationships between the symbols. That way, it could traverse semantics. Okay, so on the left side here, we got a bunch of communities that have been detected. So architecture-wise, you got a web application, business logic. Yeah, so super detailed overview of what happens, the entry points into the code base. And I think the last one is going to be done just now. Actually, so the whole point of this is you don't really compromise. You go full depth and full breadth into what you're searching for. Yeah, great. So the really important here thing is you got direct callers, and it was able to identify a call chain, so an impact hierarchy of this, and it also understood downstream dependencies, considerations, et cetera, et cetera. So this is a lot more comprehensive if you were to just use the tool, to use the agent on its own. Yep. Thanks.
Thank you so much. We do one question and then come grab him after doing the networking.
Hi, super interesting, thanks. Quick question. So when you started 1.5 years ago, my experiences was exactly the same. The tools were simply not good enough the models were simply not good enough with tool calling and search and all of these things. So, but then over time, they became so much better that at some point, the harnesses that we used to build around, let's say, GPT-4 or then Claude, became more of a hindrance than a support, and we started to chisel away of those things. from those things, and now with Claude Code 4.5 especially, with those long-running tool calls and the long-running sessions, at least my experience is that that it finds out all of this information by itself. Now, I definitely understand that using Noodle would be faster, but how did you have some meaningful way of comparing the different results in terms of quality and not just in terms of token efficiency and time?
Yes. So the short answer is that's actually what I'm doing now. I'm running benchmarks to compare. But the slightly longer answer is that this isn't really about efficiency. It's about grounding, because if tools like Cloud Code were to throw in a lot more resources at a problem, you still hit, it's still luck based, whether it's gonna go down that path or not. This is making it deterministic.
I'd love to try. Is it available?
Yeah, actually, please join the current ongoing private alpha of the tool. I'll send you an invite if you'd like to try this out. Socials on the other side.
Cool. Thank you, Youssef. Then next up is Matin with HyperView.
My name is Matin. I was actually meant to show you a project around reinforcement learning and DSPY, but actually about maybe 5 days ago or so, I was having a discussion in the HackerRoom with Antonio and Daniil, who showed you the sign language, and we came up with this idea, and we built this prototype in the last 5 days, and this project is HyperView. And essentially, it's a multimodal data curation tool. If any of you has heard about 51, like quick show of hands, like anybody heard of 51? Okay, like a little bit. It's a tool popular amongst CV, computer vision researchers, and yeah, it's mainly for viewing the data that they have and being able to create data sets. Unfortunately, the problem with such tools is that they were made in the era of computer vision, like the old era. Now you're moving to VLMs and multimodal data, and these multimodal features are simply just a bolt-on to these tools. And because they were made ages ago, they use outdated stacks. They're super slow. Like for example, 51 uses MongoDB, which makes it super slow, and it cannot represent a lot of points. And finally, I don't mean to sound like a conspiracy theorist, but they have a flat Earth problem. And what that is, I'm going to explain in a second. So this problem comes from plotting embeddings in a Euclidean space. So to show you a more concrete demo, so here, let's take for an example a hierarchical data set where you have images of animals, then you have dogs, and then you have your, a specific kind of dog, maybe your favorite animal. Like for me, it's the Siberian Husky. So here, the blue dots are showing animals, and the red dots are showing a specific dog, the Husky. And you can see that the red dot is indistinguishable from the rest of the blue dots. And this is because this is in Euclidean space. If you switch to hyperbolic space, so now you're plotting hyperbolic embeddings, which are being plotted on a hypersphere, you can see that they're much more distinguishable. So this is doing embeddings on a sphere because the volume here grows exponentially, and you have more area on the edges to represent those. So now that we've got that, because we have embeddings, now you're getting into the world of RAG and agents, and yeah. So this is actually a good use case of what Youssef talked about, coding. It's inherently hierarchical. And the main thing I want to tell here is there's some similarities between GraphRag. So for GraphRag fans, maybe this is interesting. Essentially, in the center of your embeddings, you're having more general concepts, and towards the edges, you have more specific concepts. So this essentially embeds a hierarchy into your embeddings. And to show you a more live demo, this is, by the way, the API on how you run it. This is a Python package. I will share the link later. So in this case, we're using the CFAR 100 and loading a data set from Hugging Face. So to show you the demo, this is what it looks like. So you have your images on the left side, the embeddings plotted on the right side. And if I were to select some images, I can see where the embeddings, where the exact embedding is. And vice versa, I can also select an embedding here. So now there's a tricky part. You need to use a keyboard shortcut. So here I'm going to use a shift key and then use a lasso to drag over those embeddings. And now I can see exactly which ones correspond to that. So maybe a good example, this cluster here. You can see these are motorcycles and bicycles. And you can view them in hyperbolic space. So now you can also visualize them in that kind of embedding. So finally, yeah, like we still have a long way to go. Maybe like some notes on the tech stack here, because I talked about performance. So we're using a Rust-based backend for the embeddings, and to do the visualization, we're using a WebGL-based package. So this thing makes it super performant, and you can plot as many plots as you're seeing here, and you can still move around without it lagging. So this is great. But in future, we want to move to integrating other new databases like LanceDB, training the hyperbolic adapters, and making more UI, UX enhancements. So feel free to scan the QR code in case you're interested in the project. And yeah, like Antonio, you'll meet later. Daniil showed the sign language, and myself, you can follow on X. So yeah, that's about it. Thank you.
Questions? Yep.
So, can you use the embeddings like in a vision language model then? So actually in the input, you're actually taking image embeddings and you're taking language embeddings, and then how does that map to your semantics of your language embeddings, or is there something?
Yeah.
Is that open work?
Yeah, so I did a poor job at explaining this. So here, the images, the embeddings we're using is from clip. So the images are passed to clip, and the embeddings are plotted here.
But it's just a transformation to visualize.
So you mean towards the hyperbolic one? Yeah, so right now, actually, because this is a 5-day project, it's just a simple transformation. But actually, we want to train this adapter. And then once you have it trained, you can actually find way more hierarchy. Yeah.
Thank you very much. It's really cool project. So as a user that that uses Voxel 51, so what's the advantage of having a hyperbolic representation instead of Euclidean representation as a user?
Yeah, so what we're seeing is that with the data sets that are highly hierarchical, the things at the bottom of the tree, like the very rare groups, if you were to plot them in Euclidean space, they're indistinguishable from the level above it. So in hyperbolic space, you're able to distinguish those, because to tell you, like actually a lot of data sets that appear naturally are hierarchical in nature. So so the reason why maybe hyperbolic embeddings are not at the forefront is because such visualization does not exist. So the paper I was showing you about hyperbolic RAG is 10 days old, so from 25th of November. So super new stuff.
Very cool. And then one more question. He was quicker. Sorry. Next one for you.
Yeah, just a follow-up question about hyperbolic transformation. Well, it sounds like directly from the Vatican to quantum. So, I mean, even if it's new now, well, hyperbolic transformation is not that new, and LLMs are a bit more complex, I would say. I don't know. It sounds like SVM.
Yeah, like I would certainly like to reply to that, because like what we're seeing is, I think a lot of people question, hey, why are we not already using this? If this thing is so amazing that you're telling us about it, why are we not using it? It sounds like some age-old thing. One practical reason I will give you now is that to do a lot of these transformations, so in Euclidean embeddings, the ones we use all the time, simple RAG, you can calculate a cosine similarity with your query and you get the top answers. The formula for cosine similarity is simple. If I were to show you the formula for doing the similarity in hyperbolic space, it's way more computationally expensive. You need to do more Möbius transforms and blah, blah, blah. I don't even understand that fully. So that's part of the reason. It's some things are more performant, but doesn't mean they're better in quality. So yeah, maybe with this project we can shed some more light on it.
Cool. Thank you so much, HackerRoom team. Next up is Antonio, and he is going to present a spot pattern. It's like a fingerprint. Jaguar identification in the Brazil Pantanal Park. Did I get that correct? Cool.
For doing my presentation, I wanted to answer this question, this last question about like, how is this like different and new? Is it not like the same as a support vector machine and whatever? Who asked this one? You? Okay. So it's tricky to train a vision language model to perform well in hyperbolic space because the hierarchies of concept behave differently between images and language. If I have an image, I could say that the things that are more general are the objects in the bounding box. This is because I can have the same object in many different images. But the scene itself, like the whole picture, is like the more specific thing. It's different with language. This hierarchy that Matin explained, for example, animal, dog, husky, behaves in a different direction. So you also need to curate your data set when you create your vision language model considering these hierarchies. And people usually don't do this. I got into this project, I got interested in this because I want to do this for a taxonomy of plankton. I'm working with some people who are doing this for aquatic images, and they also need to collect like the different species of plankton using a taxonomy like what you have in a tree. And this is something that happens very naturally in hyperbolic space. So it's very difficult to actually curate the dataset correctly so that this actually makes sense. You actually need to have a good taxonomy for what are the animals and what are the classes. And this is something that has this big trade-off in training, but has payback in making this very nice tree interpretable and keeping things that are supposed to be close to each other, like the most specific things, at the edges of this hyperbolic space. So it's more complicated, but it's also more interpretable, and it's cooler in this respect. Most people don't actually use hyperbolic embeddings because you can get a similar effect by making your embeddings in Euclidean space like 3 times bigger. It actually gives you something that kind of has a similar effect, but still has like this flat Earth effect that Matin was explaining, like everything is collapsed together. Okay, so stop talking nerd.
I'm starting the timer now.
Timer to myself. Okay, so I'm a computer scientist, and I started a company where I actually just teach people stuff. That's why I started this presentation teaching something. Like I do this with a couple of bootcamps, and I also do this with NVIDIA. And this is all the people who are involved in this particular project that we're talking about today. I chose to work in this particular project because I thought it was interesting from a teaching perspective. So I'm using this particular project to teach people about computer vision. And let me explain to you what is this. So we have a huge grid of cameras. In Brazil, we have some camera traps that is tracking this population of jaguars that we believe is the biggest one in the world. I say we believe because nobody really knows. And why are we tracking jaguars? Well, the real honest answer is simply because jaguars are cute. The efforts of conservation in the Pantanal Park need a face, and we selected the jaguar. So it's actually about protecting the park. So jaguars are so popular that people pay thousands of euros to go on a safari and try to spot them. This also has scientific value because we want to track the population. We want to know which are the jaguars that are alive, which are the ones who are thriving, which look sick, etc. And the jaguars actually have names, and some of them are very famous. If you Google Pantanal Park Medrosa, you will find thousands of images. And you can actually use those images to try the app that I'll show you next. So what we do is that when you go on one of these safaris, you have like a printed guide. You have a PDF guide that you flip through to try to identify if you're seeing Patricia or Medrosa or Osal. And this is how the guide looks like. You have the 2 sides of the jaguar, and you have its face. And you need to flip through this. You need to actually look at the spot pattern, which is like a fingerprint, literally. The spot pattern is unique for each side of a jaguar, and it doesn't change when they grow. When they get older, when they're cubs, they have the exact same pattern. So it's a very good way to identify them. And this is what I'm using in the model that is identifying them. So I have this segmentation of the faces. I'm doing embeddings for the right side of the body of the jaguar, of the left side of the body of the jaguar, and I'm using that to identify them so that people can use a phone app that looks like this. So this is a TypeScript demo that I'm re-implementing in Flutter. And suppose that I give a photo of this jaguar. The app is using a convolutional neural network or a vision transformer, depending on the resources of the device, to identify the jaguar and show the same information that you have in the Jaguar field guide. The front of the jaguar and the canonical right flank and the left flank. So this is for people to confirm if the jaguar that they believe is really Medrosa is Medrosa or not, and they can double check with the top 5 results. So it's a very simple app, and this is what Abby wants. So this is what we built. It has some challenges, like working with this data set is difficult because some of the jaguars are very popular. Like they go on the places where the tourists are and they don't mind the tourists. Sometimes they even try to go into the boats. And others are very shy, so we have very little pictures of them. To tackle this, we use several techniques for training. The one that has proven better so far is using the arc phase loss. This is a bit similar to the hyperbolic trick that we were discussing before. What we do is that we put the embeddings into a hypersphere, And then we use a loss that is making these classes more isolated from one another, so that the boundaries between the different individuals are easy to distinguish. And that's the technology. So if you're curious about this, and if you want to participate in this, we have an app on Hugging Face that you can try with the images that you can find on the internet. And we also are sponsoring, well, I got Voxel 51, this company that I'm now competing with because I used to work with them, to actually sponsor this prize. So we're gonna have a €1,000 prize for whoever identifies the Jaguars better. And you can find the starter notebooks to do this here. Like you can scan the slides, and this is gonna be available in a couple of weeks. You can participate in the challenge, you can improve our models and help this conservation effort. And if you do really well, then you get some money. That's
We all go to Brazil.
I haven't been to Brazil.
You have to. You have to. Cool. Thank you, Antonio. So next up is Juan, and he is gonna do a demo on robotic manipulation task with reinforcement learning and action chunking using low-cost robotic arm.
My name is Juan Pizarro, and I have been doing a deep dive and also a little bit of research in reinforcement learning and robotics during the last 5 months. And this is what is my progress at the moment. I am doing this on the robot. The robot is a framework developed by Hugging Face in order to allow the people to do end-to-end robotics. This is a project, a paper that was implemented in June, and it was merged by Le Robot in June, the same week when there was a hackathon there. The idea of this paper, that was from last year, the idea is that there is a model. When the model is being receiving the images and the information from the motors, the position of the motors, then they're doing kind of MLP in order to predict the mean and the variance of the motor position somehow. The idea is that there are two processes. There is one learner process and there is one actor process. Normally, the actor process executes a policy, and the policy normally is possible to intervene, like doing human intervention. So it's possible to get some part of the trajectory where the policy is doing the execution, but there are some portion maybe it requires some correction because this is human in the loop reinforcement learning. So it means the trajectory will contain both, like policy transition and human in the loop transition. In the other process, there is a learning process when there are multiple networks that will train at the same time. So there are, for example, the actor network that is learning to do to control the robot arm, but also there is a critic network, and the critic network is learning to evaluate what are the actions that the actor is predicting somehow. There are different buffers with different information, but this is to give something about the content what was done by Hugging Face. I participated in this hackathon in June, and this was a weekend hackathon, and this was the result of what I was able to do just with what they offer in that merge that was done in June. So he's able to push the thing. He also learned, for example, that he should go over the thing because he learned this stuff from the learning phase. So and this was, I was able to do it just in the weekend after that they merged that. After that, I decided to really go deep in the stuff, and then I was following what the lab that published the Heitzel paper was doing, and then they were moving into from Gaussian type of model into flow matching models. Also, flow matching were really interesting because probably many of you know that the first generation of image generation maybe was done by a diffusion model, but the second generation, like the later one, many of them are going more into the flow matching stuff. And the flow matching is mean you get some noise, and then the network is learning the velocity in order to transition into a specific information. In this case of images, it's images, but in this case of robotics, it means action, like action movement. The interesting part of this paper is that they also are doing distillation. So it means because this flow matching requires multiple steps But in robotics, you need that they should be really fast. So that is why they also do a second network, that is mean the one-step policy network, that they do distillation of the first one. So it means the idea is to go from noise into the robot action only in one step. So it means this could be fast. And this paper was released in February this year, and I was working implementing this on top of the robot. Then in July, they published a next paper. The name was Reinforcement Learning with Action Chunking. The idea of action chunking is that the network is not predicting just a single step, like a single motor configuration at time. The idea is that the network will be predicting a chunk of event in the future. In this case, also it means the network will be predicting that, but also the critics will also evaluate a chunk into the future. So it means you can maybe try to predict 10 steps into the future, and then the critic will evaluate the chunk as a whole, and then he will get kind of a number of how good or bad it is. And also it has some good properties, like also you don't need to evaluate all the possible steps. You evaluate one chunk, you run the chunk, you predict the one, and this is also helping learning to stabilize all the learning. So this is somehow the idea of the second paper. And I was already in this phase of learning RL. This paper came out, and then I implemented this paper, and this was the result. So this was the first working version that I had. So right now it's doing more stuff. So this is the low-cost robotic arm, and in this case it's really learning to pick the cube everywhere and then put it in those kind of balls somehow. So and this is the execution. I also participated in a hackathon. This was in the Deutsche Museum in Munich, when I was able to interact with really high expensive robotic there, and I was able to integrate that. Then I was adding rotation to the robot. In this case, you are able to see that the gripper is being aligned with the pieces, so it's able to do more natural movement. Then I started to try more complicated, like movement there. So in this case, this is a kind of multi-stage pick and place. In this case, I am picking something. Maybe it failed, but because it was doing reinforcement learning, it learned to recover from failure. He will pick that, and then he will put in the drawer, and then he will close the drawer. So in this case, this is gradually going into more like a long-term time kind of horizon. Also, I increased the control policy from 10 Hz to 20 Hz. So right now, the movement also is more fluid. So it's more natural movement, because before it was a little bit of lagging somehow. So that is because of the flow matching policies. This one also was the last one. So I was trying to also teach some dependencies there. So in this case, the idea is that this block should go first, and he needs to know that where it should release the block there, but also he needs to learn that the block should go a little bit up, and also there is some angle there, so it means he needs to really control all of this learning there. And the policy is able to learn that in the case. So they look like it's really good paper. So right now, just to finish, everything of this thing was done with ResNet-based kind of policies, the critic, the actor, everything. But right now I am moving into VLA. So this is it was last weekend. So there was a new paper coming from physical intelligence, like in November, when they were able to apply some kind of deep reinforcement learning on top of visual language action model. And then I tried to replace some component of the policy that I was working with these ideas, and it started to kind of work. So probably I started to replace ResNet-based policies or critic into VLA kind of. So that is the current status. Yeah.
Thank you so much. Questions in the audience?
Hey, really cool stuff. So I'm wondering, how do you break down the complex action into chunks? So are those chunks fixed, or you say, for example, like here you have multi-steps, right? You have to first grip the object, then you probably like compute the trajectory, and then let's say drop the object, whatever. So 3 steps. Do you break down like, is it the chunk size you predict fixed, or it's kind of it adapts to the action length or complexity?
At the moment, normally, all of this time dependency, this long horizon time dependencies, is being learned because of the dynamic of flow matching and the queue chunking and queue learning somehow. But with the action chunking, what I mean, for example, one episode, maybe if it's last maybe 30 seconds or 40 seconds, maybe there are in total 400 of steps in total. And then with the action chunking, it means, for example, I am talking, for example, 20 steps each time. And then I'm just focused on learning what is good or bad in that chunk. And then the prediction, here I do a trick. So for example, I teach the network to learn to predict 20 steps in the future. And in this case, because it's 20 hertz, it means 1 second. But that is not too much reactive. It means he will maybe he will not realize that when the PCT fell down or when he hits on the box or maybe the table. So in this case, I am running the policy at 15 step prediction, but it was training with a little bit harder like kind of task. But all the rest of, whether he understands that he needs to should first pick this one and then put into the box and then in the previous one close the drawer. This is because of this reinforcement learning algorithm and the queue chunking learning the works somehow. So the algorithm itself try to learn that. But because I am moving into the VLI direction, the idea is to be able to have more kind of multitask policies. Because this one at the moment is just single task. So he will learn only this stuff. I cannot maybe teach close the drawer and put the butter in the shaver or something like that. But with VLM, because it's language based, it will be multitask. That is the goal. Yeah.
One more question. Yeah.
Thank you for your presentation. I'm curious to know what reward function you use for those tasks. So do you punish if it falls down on the table, or do you just reward for putting it in the box? Or how do you specify that?
Yeah. In this case, I am using completely sparse reward. So it means it's 1 if it successfully achieved the task, and it's 0 if not. But the only critical part is that I saw some libraries where they don't implement correctly RL, because there is a big difference between when an episode is finished, like done, or when maybe an episode is truncated, because maybe the time of the execution is over, but maybe if the policy runs longer, he will reach the target. So that kind of a specific detail in order to really try to implement RL by the book, that helped to stabilize everything. I was trying to skip something, and everything somehow needed to make it work. But it's completely sparse, 0 everywhere, and then 1 if it's successful. Yeah.
Amazing. Thank you, Juan. So next up is Yiliu with Vibevault.
Thank you for being here tonight instead of drinking cheap boiled wine at a Christmas market. Okay, so I am here to present a product I've been working on, and I didn't have time to make slides, so my apologies. And in the car ride over, I started panicking a little bit, thinking, oh, I should probably have slides. But luckily, okay, the product is called Vibevault. And it is a standalone AI memory bank, which I have been using for the past 6 months, and should, in theory, contain a lot of information about the product that I'm going to show you tonight. So, in the Uber, I tapped out a little prompt before I got too car sick. And it says, hey, can you please check out the vault? I need to put together a 5-slide deck that explains Vibevault to a technical audience, what the product is, why it should exist, and how it works. Dig around for everything you need to know to make it really kick ass. Build it as a local Astro website. Okay, so I'm gonna copy that, throw it into cursor. Oh, the cursor. Okay, so let's make a new folder and go to my desktop. Fresh folder. Awesome deck. Oh. All right. Can everyone see this? I'm going to make it larger. So cursor, please take it away. Save my butt. All right, it's going. So while it is running, I'm going to quit text edit. We should see down here, okay, good, nice, that cursor is hitting up the Vibevault for some good old vibes. On the left here, you can see a timeline of all the MCP calls it's making. Trying to remember, like, what did we talk about that one time about the value proposition and what is a knowledge graph? Who cares? And what did we write as a memo to ourselves all those cold months ago about why we are spending 12 hours a day vibe coding this? And let's see if it finishes within 5 minutes or not. Sometimes it has a little bit of trouble with Astro here. Wait, what am I doing? Let's do this. Okay. Good. Good job. I find it really matters what you name the directory. It's actually like really important prompt engineering. So I think it'll be a better deck because we called it awesome deck. So I've gone through all the models, not to boast, but Opus 4.5 has my heart right now. Yeah. Oh. Oh, really? Okay. Okay, yeah. So, okay, just to give a bit of context here, instead of this product, Vibevault, is a centralized MCP memory bank that you can use with Claude. You cannot use with ChatGPT at the moment because they don't like MCP, but you can use it with basically everything other than ChatGPT. And so the contents of this vault here are memos and also notes and bookmarks you can drop in, but mostly memos that my different AI conversation partners have written into here over the course of the product development. And then when a note comes in or a memo comes in, the system will pull out, doing graph rag extraction, all the key ideas inside each note, bundle them up, and then display them as a little UI. And you click into, for example, apparently I'm, this is me. It has a little auto-generated summary of what this concept means in the context of this, this workspace, this corpus. And that is a part of the information that gets fed back to agents that then try to remember information in the future. Looks like we have something here. There we go. Okay. Let's see. How do we make it bigger? Where is it? Yeah. Okay. So we have a slide deck now. All right. I've been building Vibevault because I have a hunch that AI memory can be more than just a feature inside each of your different AI tools, but actually a standalone product on its own. Why would you want that? Well, first of all, memory is very important. It's the part of your context stack that lets your interactions with AI compound over time. I find for me, it helps to cut down on slop if I give it a lot of historical memory and context. But right now, it can be kind of tricky to get all that context in one place. It can take time and cause a lot of friction to feed it into all the different models every time. And so if you have a standalone product that uses MCP to make that memory available to any tool, you know, maybe, I don't know, like TikTok drops the hottest new model next week and we are all using TikTok's model now. It won't matter because your context and memory is on Vibevault and not stuck on ChatGPT. So it can be unified. The memory can be more transparent. You can literally go in and see what the system is remembering, and you own it. At the very least, you will always have access to it, and you know it can't be trained on. It can't be sold to other companies. And the high-level pipeline is kind of simple. You have a way of getting stuff into the vault. This can be done manually, or you can just tell your agent to do it after you've installed the MCP. We run some like magic under the hood to make it higher quality context, so that when it comes time for the agents to remember it, they get amazing high-level context, and also, this is hard to measure, but the vibes, like all the things that you don't even know to express about your preferences, how you work, the ideas, you know, random thoughts you've had at 2 a.m. when you're chatting with Claude, and this information in a way makes its way into the generated outputs like this slide deck. Some monospace technical specifications down there. I'm looking for early test users, so if you would like to give this a try, find me later and we'll talk. Thank you.
Thank you very much. First question.
We have questions. Thank you. You said that you can own your memory. So, what do you mean?
Good question. What I mean is that the memory features that have been built into ChatGPT and Claude and other chatbots, at the very least, is also accessible by all those product makers, right? Like OpenAI also has to store and therefore has access to all the memories. It doesn't mean that you don't have access to them, but they also have access. And then at the most, it means one day like they could go out of business or decide that like there's a European AI law that gets passed that like seizes all your content. And so when your memories are only living as a feature inside these other products that you use, you don't have the ability to guarantee access to it in the future, and you don't have a way to control who has access, who else has access to it in the future. So, I mean that may or may not matter to you, but I think like a very practical benefit of this today is portability, because ChatGPT or OpenAI has like zero incentive to let you take your entire chat history from ChatGPT and dump it into Claude, right? Because that makes it much easier for you to jump ship when Anthropic ships a better model. So on a very practical level, like if you use an external memory system like ours, then it doesn't really matter which product or model you use that morning, because it's all the same content.
Yeah, one more question here.
Can you use that collaboratively with like teams?
Not yet, but if you want to send an enterprise contract to build that out, like, yeah. No, I'm trying to make it work really well for the team of you and all your agents right now. Okay.
Cool, thank you so much. Next up is Rashid, structured memory for AI agents. So we're in the memory category at the moment.
Hello, good evening. It's nice to see so many people here. I really liked the talks. It was really amazing to see so much cool stuff built. So, who has heard about prompt engineering? Like, raise your hands. Okay, so like a lot, I think. So, can someone tell me what prompt engineering is? Like, what's the idea? Okay, so someone said it's to give instructions, right? So telling the model what to do, right? Or what to think. And the next step is also telling the model what to remember, right? So like a week ago or something, I wrote this article on, it's like teaching AI. So how can we build AI that teaches? And one of the most important things is memory, right? I need to be able to remember what my student knows, what his preferences are, what we talked about, simple things like his name, something like that. So I, as a teaching assistant, I really care about teaching. I think it's very important that we are able to do good teaching. So yes, I wanted to show like a very technical solution to how we can tell the model what to remember, right? So I built like a very simple demo app. It's vibe coded basically. Let me reload that. Yeah. So basically, what you can see here is just a very simple chat application, and here you can see the system prompt as well, and you can see here the memory. So the name, age, and so on. So this is just an example, right? You can decide yourself what this memory should have, and it depends on the domain, right? So if you, I don't have an example, but this is maybe like an onboarding agent, for example, for this language app. And I told him to ask me this information. So yeah, what's your name? So now it's going to show the tool call. So this is only one tool, which is called update memory. And yeah, it updates the name, right? So it's very simple. Like, this is not like a sophisticated idea or like a sophisticated algorithm. And yeah, sorry. And yeah, you see here the memory updated, right? So now it asks me how old I am. So I'm 21, for example. So now the age updated as well. And now I can say, for example, Berlin, let's say. And I hope it will update the country. Yeah, perfect. So I told it to use ISO codes, and you can even like have validation, right? So I validated that if it doesn't give me an ISO code, I'll tell it, hey, there's an error, please fix that, right? So I can specify the type of data I want as well, which is really important. So I know German, for example, let's say. And yeah. So yeah, it also updates that. And yeah, let's say I want to learn some Spanish, right? Perfect. And now I want to learn some Spanish for traveling. And I also just want to say, this is not like Cloud Opus. This is not Gemini 3. This is Gemini 2.5 Flash. You don't need like a smart model for that. Like it's very cheap as well. So you can also probably take DeepSeek v3 3.2. Is this working? Yeah, I don't know. Could be something wrong. Let me just send something. Okay. So yeah. I don't know what happened. So yeah, probably there was some error in the backend. Let's just try again. Okay, perfect. Now it worked. And now let's say, I know, hola. And yeah, the idea is that also the type can like change. Like, for example, vocabulary is an array. And it seems that it wasn't again an error. But yeah, so I'm not, it's vibe coded, so as I said. But like the idea I think is clear. And I hope you can use it to the full extent. Yeah, thank you.
Cool. Thank you. Questions? Yep.
Thank you for the presentation. Nice presentation. An example. It seems like it's like starting to be the machine that is trying to communicate with us instead of us with the machine every time. Is it something in this direction, the memory you want to do, or can you give us also an example, like for example in this?
This is actually also what I talk about in the article. So what I'm saying is that a teacher should drive the student and not the other way around. That's how I built the app as well. So it's the LLM that is asking me to do something. Because if I want to learn, I can't like be the driving force behind everything. That's at least what I think as like a teacher. I think it's very important for me as a teacher to be able to, kind of create the environment and be the initiating, the active part, while also being able to activate the student.
Yeah.
Thank you, Rashid. This reminds me of something that Cursor, for example, has started implementing, and I've seen in other AI apps where it will pop up a form, like a little multiple choice question form for you to answer. And I think that that's the beginning of a very interesting context engineering pattern where the agent is in a very structured way soliciting information from you, the human. So I'm wondering, where do you think, so right now you use this as a language instruction example, but are there other moments when you're using AI, for example, that it occurs to you, oh, if only the agent could ask me in a better way or ask me in a more structured way, this would improve the workflow?
I think this is also already like happening in code, for example. So if I give very vague specifications, like the agent shouldn't guess, right? The agent should ask me, hey, this is really vague, please tell me more because this is not enough. Like that's what a human would do, right? It's also like this initial problem that we had with LLMs, that they weren't able to say you're wrong. Like they would say, oh, you're right. Whatever you're saying, whatever you're telling them, right? I think it's exactly the same point, like giving an agent a personality, and like opinions are a big part of personality as well. Being able to say no.
Thank you, Rashid.
Thanks a lot.
All right, we are coming to our last demo. So we have, Tom is gonna present MLODA, yeah. One data access for ML and AI.
I hope you can hear me. So this application is also open source. You can find it in github.com/mloda-ia/mloda. So the idea here is in this process is that we are really looking into the problems we currently, and also in the past 10 years in my industry experience have. The companies have the data, but the access is a problem. What happens is, and we've seen, I think today, a lot of data pipelines, a lot of people built them, customized and struggled. And I think the stark reality is that that means we're wasting a lot of resources here on things which should be easy. For example, the Hugging Face thing, what we saw earlier with these 5 commands, this I've seen like 10 times with just one configuration change. Why? There's no reason for. The next question is, such a thing, how do you bring it in production in a corporate, for example? You can't. Yeah, like it's really hard. If you do, thank God the manager doesn't see, because he might go somewhere else then if it comes out. So that's therefore, and I do principles around it. The idea is to put something actually between the data users. Let's go here. The data users and the data producers. So basically, you have AI models, ML models, data scientists, but of course, a database can also be a data user. On the other side, you have databases, feature stores, APIs, files, and we put something in the middle, right? In software engineering, we have an ORM, a feature store is in classical machine learning, something which sometimes works, but a lot of people hate it actually. And so basically, if we put something in between, we really have now also 2 groups which can talk with each other. Another thing is, and this is actually not implied by this, is that if you want to build something like that, you need to separate what you compute from how you compute it. Because at the end it means that if you're developing something local, you don't want to go to the database. You actually want to maybe have a file, right? Whereas maybe the doc. So actually the technology need to be abstracted away, not excluded, abstracted away. In that sense, this is now a technical demo. It's a bit hard for the later rows, I think, but yeah, this is a HackerRoom and not business. So what you see here is you have an MLUDA observer. This is actually just an object to track something. And then we have just 2 agents. We have the LangChain MLUDA agent and the Pydantic MLUDA agent. And what we just give it is this tracker object. So that in the following we can track something. The idea is there to just track informations like, damn it, here it's in the way. Can you see it? That we can track things like configuration, so options, right? We can track names. We can track lineage. What? I will show this later. So this is just the setting up of the agent. The agents are still haven't done anything. The next step would be, hey, how can the agents use MLUDA? And there to understand this, you have the graphic earlier, right? We're split in the middle. If we have here explicit definition of a pipeline, we do step A, step B, step C, then this agent will not be very functional, right? It will do one thing. Then we have the workflow, which at the moment I think I would maybe, this is my number, 99% of all agents are workflows because they cannot compare the data. And actually it means we need to change here. We need to build actually data pipelines, declarative, implicit. And for that, I hope I can click it here. So for that, we just create these features, right? This is stolen from feature stores as a concept. I don't have the time to explain that. So basically, you rather say what you want as a result, not the A or B or C in the step, but you describe the result. You say, for example, you want the context exemplar feature name, so it's a string, assembled feature in this case. And this one you can configure. And this configuration, the LLM can easily do. And what happens actually when the LLM earlier, the agent chose the configuration, it will go just into MLUDA, right? It's just an API, it's a Python framework, and it will just return the result. So just a very simple API. You can plug it behind anything, MCP, A2A, maybe your own REST service, does not matter. But the interesting thing is, basically LLM just uses as a tune call. And okay, so let's run the test here. Basically the models, and then I make it bigger. This example. And what you can see, that we run the example, we don't show the output data because that's interesting, but due to the structure of MLUDA that you put it in the middle, you can now have the whole lineage, how it was configured, and actually what happened. And with this, you can track at the end basically everything you do in the data processing. And this is actually what we want, reproducibility in our agents. Because the LLMs are hard to reproduce, and we should not add their more undeterministic processes. Yeah, that's Amruda for you. Thank you very much.
Questions? No questions. Then you can grab him afterwards. Ah, there's a question.
So I guess a really nice problem you're dealing with. One major issue with such solutions is basically the next step where you're going to host that, right? Because you're probably going to create lots of connections with different data points in the enterprise, wherever it is. So this brings one potential problem. That's why it makes it a bit tricky. Second one is the authentication pattern. So in order to support, I don't know if they use Jira, Confluence, GitHub, GitLab, whatever solution they have for data points, it needs to be some, I guess this first problem is not yet solved. So if you also even solve such a Okta for agents, for example, or something in that direction, which is like reliably solve that problem first, because before accessing data, you need to authenticate your agents, right? So I guess that would be maybe something maybe also helpful if you look into it.
I think this is, okay, I mean, so the first authentication, I mean, you can authenticate the data you allow to the agent. So, I mean, if you run it, let's say we go a bit more to ML, because it's easier to explain. An ML in your data science is a Jupyter notebook, right? There you also authenticate yourself in the notebook, and then you run the agent, and this notebook then has the permissions, and this way you can, via SSO or whatever you want to use, LDAP, you can move the token around. I didn't introduce the plugin system behind it, but actually there you can do the authentication. So that's the second part, and the first part is the original idea came from a feature store, which is very central, and this one has one issue, which is if you have too many data sources, then it gets complicated. It's also a data catalog issue, some might know. But this framework is designed actually decentralized, because I had this issue with feature stores, and if the organization is too big, that's bad. And the second, if the organization is too small, it's as well also bad. And that's why it's actually a Python library, which you can spin up on your laptop, and you can spin it up in the cloud. And you just need to then have the right plugins there. Of course, the plugins need to be implemented somehow, but since, sorry, it gets a bit long, but since you don't have the whole pipelines, you can now just share and implement step A or step B and step C, because there's no secret in there. The data secret is always the whole pipeline with the configuration. Basically, we can make a shared data board. You can, for example, a hyperbolic thing you can plug in, share it in 2 seconds, or other things with robots. It's quite easy. So actually, this is what I try to solve, right? This how to make actually data in an organization also accessible. Yeah.
Very cool. Thank you, Tom. So that concludes the official 10 demos of the evening, but we have one more from Adi. How's the energy? Are you ready for one more? Woo! So Adi is going to be demoing distributed GPU compute for CFD.
Yeah, I'm not going to use LLM today. Yeah, so we actually recently started working on this project. What we are trying to do is actually do simulations, and the simulations which we are focusing on is fluid dynamic simulations. And we are also using AI models, and that brings us to the physics-based ones. It's from NVIDIA. So what essentially it's combining the AI models and making it much more domain specific. And the way they do it is by using the loss function and boundary conditions. It's a whole architecture of its own. But what's the crucial part is that it has several models. Like you can pick and choose the same way like LLMs. You have diffusion-based models. You have the transformer models. You have voxel-based models depending on the use case. And the crucial ones are called neural operators. This is what we are actually focusing on. The crucial difference is the neural networks are called as like pointwise evaluations, but whereas neural operators try to learn the spaces. So they're much more suited for understanding the simulations and replicating it. So what we tried was, for a hackathon, we had to train we had to train a model in a federated manner. So we have GPUs. We had access to different GPUs, and we could split the model and train it, and then evaluate these simulations. What's the big deal is, or why we are doing it is, the use case is actually, this is a cryogenic tank. So it's like any tank, but it's made of composite materials, and it needs to withstand extremely high pressures and very low temperatures. And yeah, you could have actually gases packed in as liquids. And what they are interested is in understanding how the fluid will come out of these tanks. So they're very interested in these simulations. And the problem is they don't have access to heavy GPUs or large number of GPUs. And this is where the distributed part comes in. If you can split the model and train it and then actually make sure that we can still be good enough compared to the standard solvers or the standard simulation tools, then we are in. And that's a big benefit we want to achieve. And so what's the core thing is that we have these models, especially we are focusing on the, in the AI models, as I said, neural operators, and we'll also try some transformer-based approaches, and then split these models and train them and try to benchmark for the use case we are looking at. And we do have some results, but I don't want to go in the details. So we wrote a white paper, and like happy to actually also look into the details of it. And everything, these standard starting point is simd.space. There we would find everything what is needed, and we would also update it with all the details and everything about the models. So yeah, that's it. Thank you.
Questions? No? Cool. That then concludes the evening. Thank you very much for your enthusiasm, your questions. I hope you leave inspired with a lot of great ideas. I want to thank everyone who demoed. Thank you so much. Thank for the HackerRoom cohort. It's been super exciting. A lot of nice initiatives also that have come out of it on conference, Coffee and Code. So keep an eye out for that. We are opening up applications for our next HackerRoom cohort. It's TBD exactly when it kicks off, most likely February, but that will be announced soon. Have a nice evening. Please feel free to mingle and ask all your technical questions that you didn't get the chance to. And grab a drink.